Okay, so this question is about sodium fluoride, and we're told that some toothpaste contains sodium fluoride. The concentration of sodium fluoride can be expressed in parts per million. 1 part per million represents a concentration of 1 milligram in every 1 kilogram of toothpaste. So we're told a 1 gram sample of toothpaste, that's important, was found to contain 2.88 times 10 to the minus 5 moles of sodium fluoride. We need to calculate the concentration of the sodium fluoride in parts per million for the sample of toothpaste in 3 significant figures. Now, the first thing I'm going to do here then is just identify what information I've been given in the question. I've been told the mass of the sample of toothpaste. Now, that's important because it's not the mass of sodium fluoride, but the mass of the whole sample of the toothpaste. And we can use that to find out the mass of the sodium fluoride within it. Now, we're also told the number of moles of sodium fluoride, and we're asked to calculate the concentration. So the next thing I'm going to do for myself is just remind myself of the equations that I'm going to need here. Now, I'm quite visual. I like a triangle, so I'm going to use a triangle to remind myself of these. You can just write them out, but I would recommend writing them out each time you do your calculations. The next thing I can do here then is think about how I'm going to find out the mass of sodium fluoride in this 1 gram sample. Now, if I know the number of moles is 2.88 times 10 to the minus 5, I'm then going to need to use this equation. So I'm going to need the molecular mass of sodium fluoride. Now, as always, I'm going to need to look this up on my periodic table. Sodium being 23, fluorine being 19, giving me a molecular mass of 42. So I'm then going to work out the mass of sodium fluoride in 1 gram of toothpaste. Now I'm taking my time to write out what it is I'm calculating in that step. So I'm going to do the mass equals the number of moles times the molecular mass. The number of moles is 2.88 times 10 to the minus 5. I've got that from the question. I'm going to multiply it by the molecular mass that I've given here, and that should come out there as 1.2096 times 10 to the minus 3 grams. Note that I'm making note of my units here as well. Now, we're told that the concentration can be expressed in parts per million, and 1 part per million represents the concentration of 1 milligram in every 1 kilogram of toothpaste. Now, we've only got 1 gram of toothpaste here. So 1 kilogram of toothpaste is going to have 1.2096 times 10 to the minus 3 times 1,000. So we're going to have 1.2096 still in grams of of sodium fluoride in a kilogram of toothpaste. Okay, now we're still in grams. We haven't changed the units. We've just worked out how many grams are within the kilogram of toothpaste. Now, the question asks us to work out the concentration in parts per million. Okay, so parts per million is milligrams per kilogram. Now, we've currently got grams per kilogram. So our final step is going to be to convert this answer to milligrams. And the way to do that is going to be to multiply it by 1,000, which gives me an answer of 1209.6 milligrams. Now, I want this in 3 significant figures, and also want my units as parts per million. So the final thing I'm going to do is just convert to 3 significant figures, which would be 1210 parts per million. Okay. So next question then. We're told that sodium fluoride is toxic in high concentrations, and major health problems can occur if concentrations of sodium fluoride are greater than 3.19 times 10 to the minus 2 grams per kilogram. We have to deduce the maximum mass of sodium fluoride in milligrams that a person who is 75 kilograms could swallow without reaching the toxic concentration. Now, we're told here then that they can have 3.19 times 10 to the minus 2 grams per kilogram. Now, we've got a person with a mass of 75 kilograms. So I'm going to start by multiplying those two numbers together to get the number of grams that this person can have, which would be 2.3925 grams. I then want this answer in milligrams, so I'm going to have to take that final number, rewrite that again so you can see it clearer, and then I'm going to multiply that by 1,000 to get my answer in milligrams. Now you'll notice then, so the final answer should be 2392.5 milligrams. You will notice on the mark scheme that they do prefer that in 3 significant figures. So 2390. Now while this answer is not incorrect, sorry that is off the page, my apologies. While this answer is not incorrect, they do prefer 3 significant figures simply because you've been told to calculate based on the fact that there is 3.19 times 10 to the minus 2 per kilograms of body mass. So they do prefer that in 3 significant figures, but you do not have to have it in 3 significant figures to get the answer. And the next question then. So the concentration of sodium fluoride in a prescription toothpaste is 2,800 parts per million. Using your answer to question 2.2, deduce the mass of toothpaste in kilograms that a 75 kilogram person could swallow without reaching the toxic concentration. So we've just worked out then that the maximum that 75 kilogram person can have is 2,390 milligrams. Now, the question then tells us that the concentration of sodium fluoride in a prescription toothpaste is 2,800 parts per million. Now, we were just told in the beginning of the question that 1 part per million represents a concentration of 1 milligram per kilogram. Okay, so if they can have 1 milligram per kilogram, part per million means 1 milligram per kilogram. So if they can have 2,800 milligrams per kilogram, and they've actually got a maximum of 2,390, then what we're going to do here is we're going to take the maximum that person can have, divide it by the parts per million in that particular toothpaste, and we should see that that person can have 0.854 kilograms of toothpaste, because what we've got here is 2,390 is the maximum our person can have, which we just calculated, and 2,800 is the total concentration of sodium fluoride in that tube of toothpaste, in that kilogram of toothpaste. Okay, next question then. So we've got to use the diagrams and our understanding to identify which diagram out of the 3 shows the correct relative sizes of the ions in sodium fluoride, and we have to explain how we got our answer. Now the first thing I'm going to do here then, we're told that the ions are Na plus and F minus. Now I want to know the electron configuration of Na plus and F minus. So sodium has 11 electrons. However, if we've got sodium plus, that tells us there will be 10. And we've then got F, which starts off with 9 electrons. But again, if it's F minus, it will also have 10 electrons. So I can see here then that both of these ions have the same number of electrons. Okay, if I look at their electron arrangement then, if I compare their electron configuration, I'm going to have a configuration of 1s2, 2s2, 2p6. So both of these ions have the same electron configuration. So it's not going to be that determines the relative sizes of the ions. Now the thing that is different about the 2 then, if the fluorine ion has 10 electrons, it still only has 9 protons. So fluorine will have 9 protons, whereas sodium will have 11 protons. So if I think about then the attraction from those protons to the outside electrons, this sodium ion is going to have a much stronger attraction for those outer electrons, therefore pulling them closer. So looking at my diagrams, I can see the best one here is going to be B, because even though that electron configuration is the same, sodium has more protons. Sorry if I just make sure that's clear, it's the sodium ion has more protons. So we'll have a stronger attraction for the outer electrons, pulling them closer.